Today's lesson is about multiplying polynomials, and we're going to start with elementary school. When you were in elementary school, how did you multiply 27 times 37? Well, if you were like the typical elementary school child, your teacher probably ended the lesson with something like this. They probably had you write it vertically. And then you said something like this. 7 times 7 is 49. So I'm going to take the 9 and I'm going to carry the 4. And then I have 7 times 2 is 14 plus 4 is 18. Then I bring down a 0. 3 times 7 is 1. I carry the 2. And 3 times 2 is 6 plus 2 is 8. I put that down. And then 9 plus 0 is 9, 8 plus 1 is 9, and 1 plus 8 is 9. And so my final answer is 999. Now, that's probably the way you finally ended up with it, okay? But what I want you to think about is this, really and truly. When I say 27 times 37, you're right, this is 7 times 7, but it's not 9, carry the 4. It's 49. And then when I multiply the 7 times the 2, that's not really 7 times 2. That's 7 times 20, which is 140. Now, I don't cross out the 7 and bring down a 0. This is really 30 times 7, which is 210. And then the final result is 30 times 20, which is 600. Ladies and gentlemen, all of these are called partial products. They're not the final product, they're the partial product. Of course, when I add the columns, I still get the answer of 999. But there's a very important reason why I want you to think about partial products today. If I were to use base 10 blocks back in the day, I would set it up something like this, where this is 15 times 13. And when I do 15 times 13, of course, there would end up being 10 of these. And of course, 10 times a 10 is, that's right, 100. And then I would have 10 times 3, so 10 times 1 is 10, and that's 20, and this, of course, is 30. And then 5 times 10, well, there's 10, 20, 30, 40, and 50, okay? So, of course, I would have 50 here and 30 here. And then, of course, back in the day, you would have had, I thought that was a cloner. Sorry about that. Let's make that an infinite cloner. 1 times 1, 1 times 1, 1 times 1, 1 times 1, and of course 1 times 1. Okay, and then we're going to, just for safety and time's sake, we're going to go ahead and clone this. And then we're going to clone it one more time. And let's kind of move this up out of the way. And so, of course, right here, you would have 5 times 3, which is 15. That's right. And so then what we would do is we now have our partial products. And so we have 100 plus 50 plus 30 plus 15. And of course, that answer is 195. Now, I know you've already been through elementary school and you're going, Mrs. Rose, why on earth are you doing this? Well, here's the reason why. We're going to talk about an area model of polynomial arithmetic. And we often use algebra tiles, and we will use algebra tiles tomorrow in class, but this is a way to non-verbally model multiplying two polynomials using geometry. So take a look at the bottom. At the bottom, I want you to think about multiplying the binomial 3x plus 1 times x plus 2. Well, if you do that, and you set up the area model of polynomial arithmetic, very similar to the base 10 blocks, you would have x times x is x squared, x times x is x squared, x times x is x squared, and x times 1 is x. X times 1 is x, 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 1 times 1 is 1, 1 times 1 is 1. So what do we have for partial products? We have 3x squareds, and then we have 1, 2, 3, 4, 5, 6, 7 x's. And then you have 2. So what about distributive property? Remember A times the sum of B plus C equals AB plus BC? How could we use this to solve these? And then I also have a hint here. What exponent property do you have to know to solve these problems? Well, distribute the 3x squared coefficient to 7x squared, and you get 3 times 7 is 21. X squared times x squared is x to the 4th. 3x squared times negative 2x, 3 times negative 2 is negative 6, x to the 3rd, and finally plus 9x squared. So it's very simple if you have a monomial times a polynomial. Go ahead and do number 2 by yourself. Now, I'm sure if your parents are listening right now, they're going, Mrs. Rose, I know the FOIL method. Can't I use FOIL? And yes, you can use the FOIL method if you have a binomial times a binomial. It does not work for anything else, at least at this time. This is first, outer, inner, and last. So, what are you talking about, Mrs. Rose? Well, it's real simple. The first step that you do, let's make sure we get a select tool, is to multiply your first terms together. Well, 6x times 3x, of course, is 18x squared. Outer, multiply your outer terms. Your outer terms are 6x plus 10. So 6x times positive 10 gives me positive 60x. Next, inner, negative 7 times 3x is, that's right, negative 21x. And then finally multiply the last two terms. And negative 7 times positive 10 is negative 70. Now, I always say if you do this right, it kind of looks like Charlie Brown at Halloween time. But you're not done because, of course, you have to combine like terms. 18x squared plus 39x minus 70. Please do a glossary card for this method. So, here's 2 examples. I'll do one quickly for you. First, 6n squared, outer, positive 8n, inner, positive 21n, last, positive 28, simplify, 6n squared plus 29n plus 28. Oops, sorry, 28. Stop the tape and do the second problem yourself. Now, what about the tic-tac-toe or box method? This is like the area model without the tiles. The first thing that I do is I write the first factor. Then I write the second factor. And then I make a funny looking box. Okay? And then just like elementary school, I go ahead and I find my partial products. 3m cubed, negative m squared, positive 18m squared, negative 6m, positive 12m, negative 4, and then combine like terms. Final answer, 3m cubed plus 17m squared plus 6m minus 4. Why don't you go ahead and try this one? We'll check it in class. You can also do this finding the volume of a rectangular prism. My suggestion would be to draw a picture. If you're talking about a rectangular prism that is x plus 1 times x plus 2, you can draw the picture, write the model, write the product of the terms, multiply, combine like terms, and get the final answer. Go ahead and draw this model, and when you're finished, see how far you can go, and we'll start class with this problem tomorrow. Now, are there special products you're going to need to know? Yes, there are. Let's talk about how to cheat. That is, are there certain patterns you should recognize? Please make glossary cards for these two patterns. The first pattern is the difference of perfect squares. If you have a squared minus b squared, it factors as a plus b times a minus b. It is the product of the sum and the difference of the roots. Perfect square trinomial pattern is in a pattern of 1, 2, 3. A squared plus 2ab plus b squared. The factors are a plus b squared. A squared minus 2ab plus b squared equals the difference of the roots squared. And here's examples. Make sure you have this card. We'll go into more detail on this one in class. Well, it's time to say goodbye for today, so toodles from Mrs. Rose. But listen, if you want some more practice before tomorrow's class, check out the website below. Mathisfun.com is a great website that you can use all the time. Go ahead and get this address, go ahead and look, and I'll see you in class tomorrow. Bye-bye.